Hello, in this video I'm going to teach you how to find an inverse of a non-singular matrix by using the adjoin matrix. Alright, so I'm going to teach you what is meant by adjoin matrix. So there are two types of finding the inverse, the two type of method, which is using adjoin, and another one is elementary row operation that I will introduce later. So for this video I specifically teach you how to find inverse of a non-singular matrix by using the adjoin matrix. What is non-singular means that the determinant is not zero, right? Means that the determinant of a matrix is not zero, then you can find the inverse. So how to find the inverse? So at first, you using this adjoin matrix, you need to find the determinant. All right. The first step, you have to find the determinant. Okay. You have to find determinant, followed by you have to find the adjoin matrix. All right, adjoin matrix. So third, you have to the inverse. The formula for inverse is 1 over determinant of A, adjoin of matrix A. So this is the 3 step that you must follow. So the first one, you have to find the determinant. Alright, determinant of this matrix, as I teach you in the previous video about how to finding a determinant. Okay, finding the determinant, you can use any row or any column. So for this case, I can use the second row or first row or any column they like. So I like the second row because of the 0 here. So now, then you refer to the cofactor matrix, right? The cofactor matrix, you have positive, negative, positive, negative, positive, negative, positive, negative, positive. So you refer to the sign of the cofactor matrix. Now I'm using the second row, I refer to the sign for this row. So let's look at the sign here. Then we have negative, right? So you put negative. Then the value here will be 2, right? This is the way then you put a minor for 2. Okay, followed by positive. All right, positive. The value here is 0, so you put 0 and you put the minor of 0, and followed by negative 4. All right, negative 4, the minor for 4. So now you fill in all the minor. The minor for 2, right? The minor for 2, you will delete the row and the column, right? The row and the column. So you have negative 1, 3, negative 2, 22, right? The minor for 0, you have row, delete the column. You have 1, 3, 6, 22, right? 1, 3, 6, 22. The minor for 2 is negative 1, 3, negative 2, 22, right? So now for this, the minor for 4, delete the row and the column. 1, negative 1, 1, negative 1, 6, negative 2. So you must write this as your step, right? This is called expanding the cofactors of this row, right? So now you evaluate the determinant of A. So I have to erase this away. Okay. Now very simple, to find determinant, you have to evaluate negative 2, negative 22, minus with negative 6, right? Minus with negative 6, you have plus 6. This part, of course, will be 0. Negative 4, 1 times negative 2, you have negative 2 minus with negative 6. So then you evaluate as negative 2, negative 22 plus 6. Right, negative 22 plus 6, you have negative 16, negative 16, negative 4, negative 2 plus 6, negative 2 plus 6, you have 4, right? You have 4. So here you will have 32 minus away 4, 16. So you will have 16 as your determinant, right? So this is the way. So you have jotted down that you already find the determinant of A. So now we go for the first part. We already know the determinants of A. Alright, so we have know the determinant of A is 16, right? So the first step have already done. The second step is you have to find the adjoin matrix, right? Adjoin matrix. So how to find the adjoin matrix? First, you want to find the adjoin matrix. Okay, your step 1, your step 2, you want to find the adjoin matrix. Adjoin matrix, you have to find the cofactor matrix first. Matrix cofactor. So you have to draw a bigger square matrix, right? So you have minor. So cofactor matrix, you have sign, right? The sign for cofactor matrix is positive, negative, positive, negative, positive, negative, positive, negative, positive. So very simple. So and you put all the minor first for all the element. So one by one. It's very tedious to do this, but you have to be patient while you're doing so that to avoid careless mistake. So, okay. So you have all this. Then you put the sign. This is all the minor, right? And you remember that the cofactor matrix, you have sign. So this is your positive, negative, negative, positive, negative, right? Positive, I'm not putting the positive, then I put negative this way. Alright, after this, you have to insert all the value for the minor one by one. So the minor for this is referred to 1 here. Alright, so you delete the row and the column. The row and the column, you have 0, 4, negative 2, 22. Right? Followed by the minor for negative 1, you delete the row and the column, you have 2, 4, 6, 22. 2, 4, 6, 22. And the minor for 3, so you delete the row and the column, then you have 2, 0, 6, negative 2. 2, 0, 6, negative 2. Right? Okay, double check 2, 0, 6, negative 2. Now, go for this one, is location for this, delete the row, delete the column. You have negative 1, 3, negative 1, 3, negative 2, 22. And row and column for 0, 1, 3, 6, 22. 1, 3, 6, 22. You have to fill in everything, alright? So for 4, you have 1, negative 1, 1, negative 1, 6, negative 2, right? 6, negative 2. And for this, 6, right? Location for 6. So delete the row and column. Negative 1, 3, negative 1, 3, 0 and 4. And for negative 2, this, so you delete the row and the column. The row and the column, you have 1, 3, 2, 4, right? 1, 3, 2, 4. 1, 3, 2, 4. So follow the last one, the minor for 22, 1, negative 1, 1, negative 1, 2, 0, right? Why we need to find the cofactor matrix? Because the adjoin matrix, the formula for adjoin matrix is you take the cofactor matrix, transpose. So the second step here is you need to find adjoin matrix. Adjoin matrix is the cofactor, you transpose the cofactor matrix. So now you have to evaluate the cofactor matrix, right? You have to evaluate the cofactor matrix. So, for example, you have 0, 4, negative 2, 22. So you will take 0 multiplied with 22, 0 multiplied with 22, minus with 2 times, negative 2 times 4. So you will get 8, right? You will get 8. Okay, I show you how to calculate this. It's a negative 2 times 22. 2 times 22, you have 44, right? Minus away. 4 times 6, you have 24, right? So 44 minus 24, you have 20, right? Because of the negative, you have negative 20, right? You have to be very careful when you calculate the adjoin matrix, right? So you have to be patient also, right? 2 times with 22 minus with 4 times 6, you have 20, negative 20. So for this, you have 2 times negative 2, you have negative 4, right? Minus with 0, nothing. So negative 22, negative 22 multiply minus negative 6. So you get positive 6. Negative 22 plus 6. So you have negative 16. For this you have negative 16. And the negative you get positive 16. Right? So again, 22 minus 18. Right? 22 minus 18. You have 4. 4. Followed by 1 times with negative 2. 1 times negative 2, negative 2, negative 6, you have negative 2 plus 6, right? Negative 2 plus 6. So you have 4 for this value, and the negative here you have negative 4. Okay, you have to go one by one, have to be patient. So negative 1 times 4, you have negative 4, right? Minus 0. 1 times 4, 4 minus 6. 4 minus 6 you have negative 2. Negative 2 and negative you have 2. Right? 4 minus 6 negative 2. 1 times 0. 0. Right? 0. Minus with negative 2. So you have 2. This is your core factor matrix. After you being so hardworking doing this, you have finally get your core factor matrix. Right? After you finding the core factor matrix, this is the second step, you know. So we are still on the way. So now your adjoint matrix, adjoint of A, is defined to be the core factor transpose. Do you remember how to transpose a matrix? Very simple. You change the row become a column. Baris menjadi lajur. Means 8, negative 20, negative 4. Alright? Negative 4. Baris kedua, the second row will become vertical. Will become 16, 4, negative 4. And for this row, it will become the third column. The first row become the first column. The second row become the second column. And the third row become the third column. Right? Double check. 16, 4, negative 4. 8, negative 20, negative 4. So therefore, this is your adjoint matrix. This is your adjoint matrix. Then this is the end of, first you find the determinant, second you find the adjoint matrix. You have done find the adjoint. So go for the third step. To find the inverse by using the adjoint matrix, the formula is 1 over determinant of A, adjoint of A. This is the formula. So finally you have reached the third step, right? The third step is you want to find the A inverse. The formula is 1 over determinant of A, which is 16. 16. Adjoint of A, right? Adjoint of A. So you just do bring this everything inside here. So 8, 16, negative 4, negative 20, 4, 2. Negative 4, negative 4, 2. Right? So this is your inverse matrix. So if possible, you try to multiply this scalar inside there. 8 over 16, you have 1 over 2. Right? You have 1 over 2. 16 over 16, you have 1. Right? You have 1. Negative 4 over 16. Right? You have negative 1 over 4. 20 over 16. Negative 5 over 4. Right? 20, 5, 4, 20, 4, 4, 16, 4, you have 1 over 4, right? 2 over 16, you have 1 over 8. Okay, so 1 over 8, negative 1 over 4, negative 1 over 4, and finally 1 over 8 as your answer. So you can use calculator, you can using calculator to check your answer, right? Using calculator to double check your answer. Okay, double check your A inverse. Okay, what I mean is by using this calculator, right? By using this calculator. So hope you see how I'm going to use this calculator to finding the inverse. So you have to make sure that your calculator in matrix mode, right? So you go to the menu and choose the matrix option here, right? 4. So you're choosing 4. So then you have to define the matrix. Okay, choose matrix A. 1. So you have to choose the number of row. How many row? You have 3 row, 3 column, right? So you go for 3 row, 3 column. So then you have key in the matrix, right? You have to key in the matrix. It will be 1 equal, go by row, key in by row. 1, -1, 3. 1, -1 equal, 3 equal. Then you have your first row, right? You have your first row. Now go for second row. 2 equal, 0 equal, 4 equal, right? So then have 6 equal, -2 equal, 22 equal. Now you have already key in everything, right? You can double check. So 1, you can see here, -1, 2, 3, 2, 0, 4, 6, -2, 22, right? Then after you key in everything, you pressing the button AC. Means it's already inside your calculator. So now you're going using this calculator. You can using this calculator to finding the determinant. You also can use to find the inverse. Okay, this is the way. So you go to the option button. You can choose. You can see there are many things here, right? So then, okay, you pressing this button here. So you have matrix A, determinant, right? Determinant. So you're choosing 2. 2. Then determinant of option of matrix A, right? Of this matrix A. So you key in 3. So bracket determinant of matrix A. Then you will have 16. Can you see that? You will have 16 as your answer. So now we can also get the final answer for the inverse. So how? Pressing the button AC again. Now option, right? You're choosing the matrix 3. Then you have this matrix is A inverse. This is A. So you're going to put the inverse on top here. Can you see there is a so there is the inverse. Can you see that under the x square there is a x inverse, right? You're pressing this button A inverse. Then you have matrix A inverse. Okay, so now you're pressing the button equal. Then you can check your answer, right? You check one by one. So you look at this is the inverse. So now you have 1/2. Yes, the first one is 1/2. Then pressing the arrow here, you have 1, right? 1 followed by -1/4. Yeah, exactly the same for the first row. Then go for -5/4, 1/4, 1/8, -1/4, -1/4 again, and lastly 1/8. Then you are very happy because all already correct. Double check with calculator. So alright, so this is the method of finding inverse of a non-singular matrix by using the adjoin matrix. Alright, hope you understand this video.